All right, hello everyone. Welcome back to the next lecture. So guys, today we are going to be discussing about the periodic table. So we're going to discuss the periodic table, and after that we're going to cover nomenclature. So guys, when you talk about periodic table, we talked a little bit about periodic table in the last lecture, where we saw the periodic table, we saw the protons, neutrons, electrons in an atom. We saw how the periodic table is organized. We saw that we looked at this staircase, if you remember, where the left-hand side of the staircase is considered metal. So everything on the left-hand side, everything green here is metal, except that hydrogen that actually belongs on the right-hand side, who are non-metal. So everything, if you look on the staircase, everything to the left is metal, and everything to the right-hand side is non-metal, with the exception of all these yellow metalloids that you see. So you should know that these metalloids, they act somewhat like metals and somewhat like non-metals. Okay, now we also learned, guys, different types of compounds. We learned ionic compounds, molecular compounds, and how they are formed. We learned if you take a carbon and oxygen, which both of them are nonmetals, if you combine them, you're going to make, for example, CO2. And carbon dioxide, CO2, is made by a combination of a nonmetal and a nonmetal, and that's why this compound is a molecular or covalent compound. Now, if you pick something from the left-hand side, so let's say you pick a sodium, and you pick a chlorine from the right-hand side, so you see a metal and a nonmetal. When you combine these two, you get an ionic compound. So we need to learn that there are two types of compounds, ionic compounds and covalent compounds. Covalent compounds are also known as molecular compounds. So today we're going to discuss, guys, how we can use this information and name these molecules, okay? So again, on the periodic table, guys, as we learned before, we have, what we have is we have 18 groups, so as you go up and down. So this is our first group, as you see the number 1 and the number 2, 3, 4, so on. You go up to 18, okay? Now, there's another numbering that you're seeing, which is 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. This numbering is actually even more useful. And why is that? What we're going to learn, guys, is the elements like to keep 8 outer electrons. So when we discuss this in the when we learn the electron configuration, what you see is that in the center you got the protons and neutrons. This is your nuclei, and then outside you have electrons. And outside, when you have electrons, we have different orbits or shells, or you can call them floors. So you have electrons sitting here, you have electrons sitting here. So the outer one, so the outer orbit that we have, most of the atoms like to keep 8 electrons. So if they can somehow make it 8 electrons, they'll keep 8 electrons. Or if you think about the first five elements on the periodic table, hydrogen, helium, lithium, beryllium, boron, they usually do not prefer to go as far as 8 electrons. They're happy with what they have. But usually speaking, generally speaking, atoms like to have 8 outer electrons. So for that, what they usually do is they will either remove one of their electrons so that it becomes 8 outer electrons, like that's what a lithium or sodium or potassium would do. So you see that this is a group number 1A. Guys, group 1A likes to lose electrons. And how many electrons does it want to lose? It wants to lose 1 electron. Okay, now, first of all, let's go back and think about metals and nonmetals, guys. Metals, remember, like to lose electrons. So they give away their electron. And on the other hand, nonmetals like to gain electron. And guys, if you remember from our previous lecture, that if somebody loses electron, they will become positive charge. So if I take sodium and I break it into a sodium plus 1 and 1 electron, what does that actually mean? If you take the sodium atom, you can break it into two things. You can break it into a sodium ion, and we show that with the positive 1 charge, and 1 free electron. So what we are saying is that sodium lost its electron and itself has become sodium plus 1. Now, on the other hand, guys, what do Non-metals like to do, as we know, they like to gain electrons. So let's take the example of chlorine. So guys, what does chlorine do? Chlorine takes one electron. So I'm going to add one electron to chlorine. And when you add electron, which is negative charge, the chlorine will become negative charge. Okay, so guys, this is very important for us to understand that if an atom loses electron, it becomes positive. If an atom gains electron, it becomes negative. And we learned this also in previous lectures where we learned that electrons are negatively charged. So if you lose negativity, you become positive. If you gain negativity, you become negative. Okay, so this is not like a traditional plus minus showing addition subtraction. It's not that. It's the charge of the ion. Okay, so now that being said, guys, what you have made basically, so what you have made on the right hand side is you have made a sodium plus 1 and you have made a Cl minus 1. So when you see these two ions, and you can see both of them are, this is a metal and this one is a non-metal. And if you guys remember, if you combine a metal and non-metal, we call them ionic compounds. And that is what we are seeing here, guys. So if you ever combine something from this side, left-hand side, and you combine it with something on the right-hand side, you're going to produce ionic compounds because all of these things on the left-hand side, which are metals, the green ones, they will become positive charge, and everything on the right-hand side is negatively charged. So if you combine anything positive and negative, you see you're combining ions. So what better name than ionic compound? Okay, so I hope that part makes sense, guys. So when you combine Na plus 1 and Cl minus, so let's see that here. So if I have a sodium plus 1 and I have a Cl minus 1, what we do is when they combine, guys, to make a compound, what they're thinking is that sodium is going to come in with its positive 1 charge and chlorine will come in with its negative 1 charge. In order to cancel out or balance out their charge, you will take one sodium plus 1 and one Cl minus will come together. Now you can see when you have positive and negative charge of equal amount, the charges will cancel. And when you actually write them, when you combine them, you write them like this, NaCl. You do not write the charge anymore. So when you're writing a compound like this, guys, this is an ionic compound. So we know ionic compound is made up of ions, and we realize that even when you're writing it as NaCl, where you do not see any charge, but in the back of our mind, we know it's coming from a sodium plus 1 and a Cl minus 1. Both of them have some charge on them. So yes, this is ionic compound. You do not see any charge when written in the compound form, but in the back of the mind, we know that they have a charge. So this is how you make ionic compounds. So here, basically, you're combining both of them in 1:1 ratio. Because sodium is plus 1 and Cl is minus 1, one of each is sufficient to cancel the charge. Let's change that scenario. Okay, let's take another example. We're going to go to calcium, guys. And let's go to calcium and look at it on the periodic table. So this is where the calcium is, guys. Calcium is sitting in which group number? So group number this guy is sitting in is group 2A. Guys, group 2A likes to lose 2 electrons. So just to rewrite the whole thing again, guys, so what we need to do here is we need to see that what is exactly going on with all the metals and non-metals, like how many charges are they supposed to keep? Like, are they supposed to be plus 1, minus 1, plus 2, minus 2? How do we know all that? That's what we're going to learn right now. And guys, this is going to be very, very important for learning the nomenclature. And nomenclature is going to be a big part of your first exam. And then you need this knowledge for your later exams as well. And then the final exam, you're going to see how the nomenclature questions, you're going to see them directly coming back to your exam. So on the first exam, you're going to expect quite a few questions on nomenclature, so pay a lot of attention, guys, on this. What I was saying was that when you have a group 1A, group 1A is supposed to be positive 1 charge because they like to lose 1 electron. Okay. Now, the point is that all the left-hand side, they are positively charged because they lose electrons. So guys, you should now know that metals, since they lose electrons, are always positive. Non-metals, because they gain electrons, are always negative. And you're going to see even a direct question on that. I'll ask you Do metals like to gain or lose electrons, or non-metals like to gain or lose electrons? So you should know that as well. All right, so we learned, guys, that the first group likes to lose 1 electron. So second group likes to lose 2 electrons. Now, do you notice, guys, this numbering? The numbering was, there are 2 numberings, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, and then goes up to 18. We're going to ignore that numbering. We're going to look at the other numbering, the 1A, 2A. And after that, if you see, we skip all these here, and then 3A is actually sitting here. So group 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. The idea is that for all these ones which are labeled A, for them we know the charge. Okay, so for all the A ones, we know we can predict their charge by looking at the periodic table. But for the ones which are sitting here, the ones that are sitting here, all these ones, so starting from this point, all of these here. So for all of these, again, I'm just trying to label the metals only. So guys, all of these, they're called transition metals. For these, we do not know their charge from the periodic table. We need some more information in the name itself to know the charge. And we'll learn that later when we do nomenclature. So guys, these are all transition metals. And we don't know if this SC, which stands for scandium, if it wants to lose 1 electron, 2 electrons, 3 electrons, 4 electrons, we don't know. What we do know is it does not want to gain electron because it's a metal, so it wants to lose electron. That's all what we know, but we don't know how many electrons. So what we do know again is C. Let me label this again a little correctly. So if you see when I was marking this, let me relabel this. So we're gonna go here, and then I'm gonna keep these 3 out, guys: aluminum, gallium, and indium. So these 3 guys actually under group 3A are supposed to be +3 charge. I'm not gonna put +3 charge here because all of these things down here are not +3. Only these 3: aluminum +3, gallium +3, indium +3. All these are +3. So guys, we learned that all of these down here are +1. All of these down here are +2. Then these 3 are +3. Okay, then there are some exceptions, guys. You can mark this on your periodic table, like zinc always likes to be +2. Cadmium also likes to be +2. Ag likes to be +1. Au likes to be +1. Hg is very different. Hg wants to be this. Hg 2, 2 plus. That's what this guy want to be. We'll talk about that later, okay? But the idea is, yes, that most of these here are transition metals for which we do not know their charge. And guys, this charge is also sometimes known as oxidation state. When we later are going to learn covalent compounds, we're going to see what it means by oxidation state. But for right now, the charge that we write on the top, like when I say sodium +1, I can ask you what is the charge of sodium in this case. You will say it's +1. I can also ask you what is the oxidation state of sodium +1. Your answer will be the same, that it's +1. Okay, so again, we learned this group 1 is +1, group 2 is +2. Then in group 3, only these 3 guys are +3. And then we learned some exceptions that even these transition metals have a fixed charge. And you should have these labeled on your periodic table so that you have this for your reference. So now, guys, what we need to do is we need to look at our look at the other side. We need to look at the negative ones. So again, we got these as +3. So all these are +3, +3, +3. And now we're going to go on the right hand side. And guys, look at these ones. So what are these called? These last one here, this whole group is called noble gas. And guys, we should know these names as well, that they're called noble gas or also called inert gas. Okay. They're very noble. They do not want to react. That's why inert word is also used. So there are 2 words in chemistry, something that is inert and something that is reactive. So things on the left hand side, they're reactive, but group at number 8 or group number 8A or group number 18 they're called noble gas or inert gas. And they're very, very stable. We'll talk more about that later as well. So the point was that these, starting from here, guys, these nonmetals, the blue ones that you see, so group number 7A, guys, they're all supposed to be -1. You guys remember why is this negative? Because nonmetals like to be negative. So when you start from the right-hand side, do not start from the helium group because all this is charge 0. So start from here. This guy is -1, -2, -3, and this one, guys, I'm going to label ±4. Because when it comes to these, to this example, let's say carbon, carbon, guys, can go either way. It can be +4, -4. It's in the stage where it can lose 4 electrons or gain 4 electrons. It's going to be a same thing for carbon. So usually what you're going to see is carbon will not even participate in making ionic bonds. It will only participate in making covalent compounds or covalent bonds. Okay, like carbon will combine with oxygen to make a covalent compound. Okay, now, so what we learned, let me just quickly summarize. On the whole periodic table, we got some things that have a fixed charge and some things that do not have a fixed charge. So metals are always positive, non-metals are always negative. Then the non-metals are always negative and their charges are fixed. So metals are two types, fixed charge, not fixed charge. Let me summarize that here for you guys. And we'll come back to the calcium as well. So what I was trying to say here is that we have metals that are two types. Sorry about that. So metals are two types, type 1 and type 2. Type 1 are the ones where we have the fixed charge. And who has fixed charge, guys? If I go back to the periodic table, you guys remember all of these are +1, so they're type 1. All of these are +2, so they're also type 1. You guys again remember, I'm saying type 1, okay? And type 2. These are two different definitions. So type 1 is when the metals have fixed charge, and type 2 is when metals do not have a fixed charge. So no fixed charge. So if I try to make a list of all the type 1 metals and a list of type 2 metals, let's do that right now. So these are metals again, guys. This is the classification of metals. So type 1 metals are the ones that have a fixed charge. So who has fixed charge? Group number 1 has fixed charge. For example, lithium, sodium, potassium, rubidium, cesium, francium, they're all +1. So they're considered type 1. Guys, again, type 1 does not mean +1 charge. Type 1 means fixed charge. It can be +1, +2, or +3. So you got group 1, then you got group 2, and then in group 3, we learned only these 3 have a fixed charge. So group number 1, group number 2, and then when I say group number 3, we should know it's only aluminum, gallium, and indium, and they're all going to be +3 charge. Group 1 is +1 charge. Group 2 is +2 charge. So remember, guys, type 1 does not mean +1 charge. Type 1 means fixed charge. It could be +1, +2, or +3. Then we also learned some exceptions, that zinc is +2, cadmium is +2, Ag is +1, Au is +1. We also learned Hg2 is 2+. So all of these, for which we know the charge already, they are type 1 metals. Then all other metals, so all other metals for which we do not know the charge are type 2. So that's a simple definition. So the ones which are not type 1 are type 2 metals. So all other metals, charge not fixed, we already know that. Okay. All right, now guys, for non-metals, we do not have any type. Non-metals are, all of them are fixed charge. Non-metals are fixed charge, meaning I can look at the periodic table. So I can look at the periodic table and predict the charge. So I can look at the periodic table and ask myself, nitrogen is going to be what charge? It's going to be -3. And then if I go and ask you chlorine is going to be what charge, you automatically know it's going to be -1. If I ask you oxygen is going to be what charge, oxygen is going to be -2 because we know the group number. So all of these are -1, -2, -3. And don't worry about carbon, guys. Carbon does not even participate in ionic bonds, usually speaking, okay? All right. So now we got the idea that our metals and non-metals are, metals are two types, non-metals only one type. So all the non-metals have fixed charge, and the fixed charge ranges from -1, -2, and -3. Again, carbon we can keep as plus or -4. Okay, so now guys, if you remember when I was giving you this example of how you make compounds, This only works for ionic compounds because ionic compounds are the one who have the charge, and making their formulas can be tricky. Now, what do I mean by that? So let's take the example, guys. If I ask you on the exam, if you take a calcium and if you take a chlorine and you combine them, what are you going to make? Like when you combine sodium and chlorine, you make NaCl. That's simple. When you take Ca and Cl, do you make CaCl? No, that's wrong. I mean, the way we're combining them is wrong because you guys know that calcium is a metal, so it has a positive charge. And so Cl is a non-metal, so it has a negative charge. So if they have a positive and negative charge, do we know exactly how much positive and negative that charge is? Yes, we know that from the periodic table. So look at calcium. Calcium is sitting right here. Calcium is supposed to be positive 2. So I'm going to go back here and change my calcium to a calcium positive 2. And tell me, guys, what is chlorine going to be? So calcium we know is calcium positive 2. And Cl is what? Cl is negative 1. We already know that from the periodic table and even from the last example. So now when I combine these, guys, what do? So ask yourself. So there are two ways to do this, okay? Well, first is conceptual way. We're going to do that first, and then we're going to do the quick crisscross method. So if I ask you, there's one calcium with a positive 2 charge and a Cl with a negative 1 charge, then can you tell me if I want this calcium and chlorine to fight with each other and I want this to be an equal competition, how many calcium and how many chlorines do I need? Or basically ask yourself, if I have a +2 charge coming from here, then how many -1 charges do I need to cancel off that +2 charge? So in order to balance out the charge, if I have a positive 2 charge, I'm going to need 2 of these -1 charges. So when I say I need 2 of these, what do I mean? I need another Cl minus because you know that you cannot make Cl -2. You cannot change that to -2. And you cannot change that calcium to +1 because their charges are fixed. It's not in your hands. But what is in your hands is you can increase how many chlorines and how many calciums you bring in. So if you're bringing in one calcium, which is +2 charge, and you're bringing in two Cl, each one with -1 charge, so that the total becomes -2, and that -2 will cancel this +2. When we're thinking that, what we do is, how do we write this in the formula? We just need one calcium, so we need one calcium. And we need how many chlorines? We need 2 chlorines. So the number, guys, that you see in the bottom here is how many atoms do we have? So calcium, we just need 1. And chlorine, we need 2. Now, something to keep in mind, guys, whenever you're writing the formulas and you have 1, you never say 1. Because if you just say calcium, just writing calcium, that's the presence of the symbol Ca, is telling me that there's 1 calcium. So you do not have to write number 1. Like in NaCl, you don't write Na1 and Cl1, right? So this is your actual formula. So CaCl will be the wrong answer. So CaCl is the wrong answer because you forgot about the charges. CaCl2 is the right formula. Again, what is this telling us, guys? That one calcium with a +2 charge is going to need 2 chlorines, each one with -1 charge. So if I combine that, I need 1 calcium, so I just need 1. And then for 2 chlorines, you put a number 2 in the bottom. Okay, so once you make the CaCl2 like that, let's do the second way of doing this, okay? So the second method was when you write calcium +2 and Cl -1, the crisscross method shows us this. Sometimes it's up to you which method you like more, guys. That was a conceptual method. This is more like a trick that you can use. So what you do is you take the number that you see on the top of calcium, you put it down here below the chlorine. And the number that you see here, just the number, okay, not the sign, you put it down here next to the calcium. So calcium is going to be getting what number, guys? Calcium will be getting this number 1. So this number 1 will come down here. And we learned if it's number 1, if it's 1, we don't have to put 1. And then Cl will be getting what number, guys? It will be getting 2. And please remember, guys, to forget about these signs when you're writing the numbers in the bottom, because the bottom numbers tell you what? They tell you how many atoms do you have. So there's no way that you're going to have -1 calcium. Like it's like saying that I have -5 students in the class. Is that possible? No. So always ignore the charge that you see here when you're writing the formula, when you're writing how many atoms do you have in the formula. So CaCl2, guys, you can get to this answer even by this crisscross method. Okay, all right. So now, guys, what basically we have learned is we have learned that how do you make ionic compounds. Okay. So basically we learned also how the product table works. We learned that on the product table, we have metals, not metals. Metals are positive, non-metals are negative. Which one is how much plus one, how much charge positive, like plus one, plus two, or plus three. And if they're negative, how much negative, negative one, negative two, negative three. And then we learned some exceptions like these ones here that have a fixed charge as well. Okay. Now, and if I ask you, tell me V, which stands for vanadium, can you tell me what kind of metal is it, type 1 or type 2? It's type 2 because type 1 is fixed charge. V is not a fixed charge. We cannot look at vanadium and tell what is the charge going to be based off the periodic table. So that's why they're called type 2, no fixed charge. Okay,